Here comes part 2 of our exercise in solving trig equations. At the end of the last video, I asked you to look at a few questions in the textbook, and I hope you've had a chance to at least attempt them before looking at this video. This first question says tan x cos squared x minus tan x equals 0, and your first instinct might be to replace the tan x with maybe sine over cos, but another approach would actually involve factoring. There is in fact a common factor between those two terms. That common factor, of course, is tan x. If I factored out that tan x, I would have the following: tan x into cos squared x minus 1. Okay, well, how does that help us? It helps us because now we can apply the zero product law to what we have in front of us. You don't have to have sine throughout the equation or cosine throughout the equation. You can have tan and cosine and sine all in the same equation, but if they're factored, then you can take each one of those factors and set them equal to 0. For instance, why don't we take tan of x and set that equal to 0 and solve it? Now, to solve this, we just simply set the x to the inverse tan of 0. Of course, we're just trying to find where tan is 0, and it's 0 in the following places. It's 0 at 0, pi, 2 pi, minus pi, and minus 2 pi. You might need to review how the tan function works. Just remember that tan is the ratio of sine over cosine, which is a y over the x. Just go back to that unit circle that we started off using when we were looking at the three ratios. On the other side of this, of course, is that the cos squared minus 1, cos squared x minus 1, is equal to 0. We can solve that as well. Turns out that when you solve this and you set cos squared x equal to 1 and cos x equal to the square root of 1, which is plus or minus 1, that all of the answers are actually the same as for where the tan of x is equal to 0, and you can go ahead and review that on your own. The answers are x is equal to minus 2 pi, minus pi, 0, pi, and 2 pi. The same answers that we got before also apply to where the cosine of x is equal to both plus and minus 1. The next question is probably something you would come across in maybe physics or some other science class. We have an equation that gives us the voltage for a circuit in a trigonometric equation, which is 167 sine 120 pi t. And what we need to do is to try to figure out if this voltage is going to exceed 120 volts for a sustained length of time, because there's a component which cannot handle a voltage which is more than 120 if that happens for more than 0.01 seconds. All right, it can handle it if it's 0.01 seconds or less, but if it's more than that for a sustained length of time, then we have a problem. All right, so first thing we need to do is to analyze the equation, and the amplitude of this equation is 167, the A, and the period would be 2 pi divided by the value of k, the k in this case being 120 pi, so that's 1 over 60 when you reduce it down. And what this means is that the voltage cycle actually takes 1/60th of a second, because remember that time in this case is measured in seconds. So a period which is 1 over 60 does suggest that it's a 60th of a second that it takes for the whole voltage cycle to take place. Well, another way of looking at that is to say that you have 60 cycles in 1 second, because if one cycle takes 1/60th of a second, then in 1 second you will cover 60 cycles. Okay, let's see if we can sort of give you a visual of that. Here's a graph that has time on the x-axis and voltage on the y-axis. So this is very rough now. If I started off at the origin and sort of did an up and down motion, this is very rough, folks, you know, I don't draw very well. All right, that's going to happen, and these cycles, 60 of them will take place within 1 second. This line up here represents the 120 volt line. So what that means is that I'm actually saying that when the cycle goes over 120, which is in these regions here, so between here and here it's over 120, and it drops below that, and then it does the same thing again over here. The question said in each half cycle, so a half cycle will be from here to here. So in each half cycle, for some period of time, the voltage actually goes above 120 and then goes back below that. And that's what we're really trying to find here. Okay, so let's go back and look at the question again. And we're going to take this as kind of like an inequality. We're taking 167, 120 pi t to be greater than 120. Although it's an inequality, I'm going to treat it almost like an equality. First thing, of course, is to divide both sides of the equation by 167. As I've done that here, you'll see that the sine of 120 pi t is now equal to 120 over 167. Okay. That means that 120 pi t is equal to sine to the minus 1 of 120 over 167. Right? When you have the sine of something being equal to something else, then that thing that you took the sine of would be equal to sine to the minus 1 of the 167. Okay? Or 120 over 167. Okay, so why don't we continue solving this and say that 120 pi t is therefore equal to 0.8217. That's in quadrant 1. Remember that when you get an answer from the calculator, it's really only a deviation from the x-axis. So the 0.8017 that you get from your calculator when you take sine to the minus 1 of 120 over 167 is a deviation from the x-axis, which you must now apply in quadrant 1 and quadrant 2. That's where, of course, sine is positive. That gives us that t now must be equal to that number that we got, so the 0.8017, which is in quadrant 1, and the 0.2399 in quadrant 2. We're going to take that and divide that by the 120 pi. And that gives us these answers. T is equal to 0.00213 and 0.00621. So what that means is that, we go back to my little rough diagram here, this first point here, though it doesn't really look that obvious, is the 0.00213. That's when it's actually equal to 120. Then it goes above, and when you get down to the second value when t is 120, it's 0.00621. So in between these two is where you're above 120. So how much time has elapsed between those two? But obviously what we need to do is we need to find the difference between them. The difference between them is 0.004 seconds, which is less than 0.01 seconds. And all that means is that the time, if we go back to the question, the time is so short that this particular component is going to be safe. The question asks, is it safe for this component in the circuit? The answer to that question is yes, because it's only above 120 for 0.004 seconds, which is less than 0.01 seconds. So that means that we're safe. Let's go on to the next question. We need to find solutions for this. Well, I think you probably realize that this is kind of bringing in some of those trig identity skills that we had before. So what I would do is I'd look for that common denominator, which is of course the product of the two denominators now. So 1 plus sine x times cos x would be that denominator. Using that as my common denominator, you'd of course get what I have on the screen. So cos squared x plus 1 plus sine x squared. Of course, you know that you now need to take the numerator, that's squared, this part numerator, that's squared, and square it. Now don't yet make the mistake of thinking you're going to just square the first and square the second. Remember, you square the first, you take the product of these two and double it, and then you square the last. So your result should look like this. So you get your cos squared x, which is the first term. You get 1, which is the square of the 1. You get 2 sine x, which is the product of 1 and sine x doubled, and you get the sine squared x. Well, please remember that sine squared x plus cos squared x is equal to 1. So what that means is that if I were to put together this sine squared x and this cos squared x, I'm going to get 1. So here's a 1 I get from doing that. That plus this one that was there before, plus the 2 sine x is a result of simplifying that top. And of course, these two are like terms, so I'm going to get 2 plus 2 sine x there. And if you think about it, it means that I can factor out that 2, leaving with 1 plus sine x. Now, here's where, a lot of you would recognize that you can actually now reduce this by taking these two out, because they're common factors of the top and the bottom. It's okay to do it this time because they are both factors, they're both products. That leaves you with 2 over cos x is equal to 2 over 1. But the important thing to recognize here is that they both have the same numerator. So if the two numerators are both the same, 2 on the left and 2 on the right, then it means that their denominators must be equal to each other. And here is what that means. You're going to end up with just simply that the cos of x is equal to 1, right? If you were to cross multiply, you'd get the same result as what I just got. So really that's all you're solving. Where is the cos of x equal to 1? And the result of that is it's equal to 1 at minus 2 pi, 0, and 2 pi. And that's it.